Hi everybody, Cuiv here. Well, Dwarf Laboratories has graciously sent me a Dwarf II portable telescope, and rather than doing a typical review, they actually had a request that I produce a video for beginners on astrophotography, covering how to do an outdoor setup, basically on the process of getting set up and getting started in astrophotography. They also requested I do another video on how to process an image after I collect data using this Dwarf II telescope. So this first video is just going to be on getting started with astrophotography. I'm Cuiv and you're watching AstroQuest 1. Okay, I first want to talk about finding a good location to image from. Ideally, that place would be in an open area without a lot of obstructions and not a lot of street lights or anything else like that. Presumably in a designated dark site. And to find what kind of area you have in your area, and maybe there is some dark sites in the area where you live, I'm going to go on the computer and show you a program that'll assist you or should help you out. Okay folks, well, I'm on the site called lightpollutionmap.info, and when you click on it you get this. The first thing you want to do is go to your location, and one way to do that is just to go to your location, and it'll automatically go to Monroe, Connecticut. Now the second thing you want to do is, if I click on this button right here, it'll give you this little pop-up, and you really don't want this little pop-up. The reason is because it doesn't really give you that much valuable information. What you want to do is come over here to where it says Overlay. You want to switch it to World Atlas 2015, and then if we click your location, it'll give you these values right here: zenith, sky brightness info. This is what you really want. And your values that say SQM, those are very important. The higher the number SQM value, the better your site is, the darker it is. And another very important value down here is where it says Bortle, class 5. The Bortle is also another indicator of your sky brightness, and in that, the lower value you have, the better it is. So I'm at class 5. That's okay, that's in the middle. Bortle class 1 would be the best, and Bortle class 9 would be the worst. So let's click off that, and we'll scroll outwards a little bit. Oops, that's scrolling inwards. And we'll see what my area is around. And you can see where it gets green and blue. Those are really, really nice areas of darkness. If you look over here in this region, over in western Pennsylvania, this is where they have the Cherry Springs Star Parties, famous locale, and I can click over here and you can see the Bortle class is class 2, which is really good, which is why they hold those events there. And the SQM value is 21.9. Now going back closer to home, let's look at downtown New Haven, and we can see going into New Haven, you really wouldn't want to do any imaging from there. It's 8 to 9, which is the worst. And you can see the SQM values are 18. So not a good location to do imaging from. But let's look at some other places around home. You don't really have to go that far in order to get better skies. If I go to the next town over, I'm at Bortle class 4. So that's a big improvement. So you can just go around and look at your areas around where you live or where you want to do your imaging to see if you have a better site. Now, if we go to hybrid map, this has an overlay much like Google Maps, so it gives you a better indication of your area. You can actually take this away and you can actually have a better idea of the topography of your area if you're trying to search for a site for an off-site location. For example, My house, as you can see, is in the middle of the forest. It's not a great place to image from, So sometimes I might want to go off-site. Well, there's this cemetery over here, not to be morbid, that I go to frequently. The Bordeaux class here is still the same, and the SQM is still roughly 20.3 or 20.4. But the good thing about this location is, if I use the image right around here, you have a much better field of view. Now, I've actually contacted the owners of this cemetery, and they said it's fine to do imaging from there. There's a little gate here, but it's open at nighttime. Now, if I do want to get better dark skies close to home, why, I would just come over to that next town over, as I was talking about. There's a little park right here. It's called Payne Park or something like that. And it's got a Bordeaux class of 4. So this is a really dark location. The one thing with this location is it's not as open as that other location where the cemetery was, but the skies are a lot darker here. So, you know, even that going down that one level makes it much better. So this is a handy map to have, and it's called Light Pollution Map. Okay, just to let you know, most astrophotographers eventually end up doing a lot of their imaging from their own backyard or front yard, somewhere at their own house. But if you are going off-site, it's a good idea to check the skies and check the area prior to your imaging. Okay, let's go to the next step. Okay, for this next step, we're going to go take a look at how to choose a target to image. And for that, we're going to use the computer again. All right, so for this first program that I'm going to show you, it's called Telescopius, and telescopius.com. I'll provide links in the description section as well. But I've actually got an account with them, but when you first open it up, it'll look something similar to this. And you'll notice over on the left side, it gives you daylight. This right here is midnight, where it's midnight, and this is the next day. You'll notice that in the daylight, it gives you this little bluish color thing, and then right here is where it's transitioning into nighttime, and so then from where it's black, this is the nighttime. So this is your imaging window, and it tells you with the sunrise and sunset, and it also tells you astronomical night, because the sun may go down at 8:19, but it's still kind of dusk outside, and you don't want to be doing any astrophotography at that point. So you want to wait till it gets dark, and so this is when your imaging window is. Other good things it tells you clouds. Right now it's okay outside, and the seeing's good, but later on it may not get that way, so it tells you the weather conditions. And also, if you click over here to targets, by golly, deep sky targets, it'll just give you a whole list of deep sky targets that are available at my location. And if you look over here, this is your imaging window when it's in the dark, and you'll see this isn't really coming up until like 2 in the morning. That's what it's saying for Pleiades. So it's probably not really, if you want to get a couple hours in, well, you're going to be up pretty late, but even before it rises. Look at this thing. This thing's really good. And this thing, by golly, as soon as right after dusk, it's visible, and it's pretty high up. It's 69 degrees, and they'll be with us for pretty much the entire night. So that'd be a good one for me to do. So this is Telescopius, and it does a lot more than just what I'm showing you. Just this. I'm just trying to get you started. So this is one of the things I use. Another really good program that I use for finding objects, and I probably use it a little bit more, and that is this program called Stellarium. Well, folks, I'm going to give you the Reader's Digest version to Stellarium. Stellarium is a very powerful program, and it can actually run your telescope. But I'm going to give you, like I said, a real quick overview. I had cleared all my settings, so if you download Stellarium, which is a free download, you would get something like this. It has a landscape image already here that's someplace in France. I can't pronounce the name. But anyways, it's pointing to the south. If you just scroll around, you can actually go to different directions: west, north, east, and back to south again. So one thing you want to do, or could do, we're going to look for objects to image, and right now it's in the daytime, so you want to make it nighttime by coming over to this side, and there's a toolbar here, and you just want to click the one that says date and time. So we just click over here and we make it night. And here we are at like 10 o'clock at night. And we look and voila, we see the night sky. And you can actually see a lot of these little things that are labeled. Those are objects that you can image. So that's why this program is really good. You can look and see what's available. I like to also come down here. There's another toolbar down here. And if you click on this azimuthal grid, it provides a grid on here. So it'll give you an idea of how high up things are. If you look at this thing that says the Lagoon Nebula, well, it's at 24 degrees at that time of night. So that'll give you a height, and it tells you the direction. We're near south direction at about 24 degrees. You'll have an idea of where to look in the night sky. So very powerful program. Another thing you'll notice on here is you'll see these different things. It has an X over here, like that circle with an X. Those are actually globular clusters, so it tells you what type of object it is. We can get a better view of it. Okay, so that's the globular cluster M15. You'll notice these squares. It has squares over here, and these are actually nebula. The squares are some type of a nebula. So let's take a look at this one called the Eagle Nebula. Oh, and by the way, when you click on the object, it tells you what the object is, and it tells you the other designations. So the Eagle Nebula is also called M16. It also goes by NGC 666 and IC 4703. And here's what that looks like. Okay, so we've got these are globular clusters. These squares are some type of nebula. We have these open type things. These are just regular clusters, star clusters. So they're not globular clusters, they're another type of cluster. I don't think I've ever imaged that one before. And what about galaxies? Are galaxies on here? Oh, it actually has planets on here too. So if we scroll into the planets, if you scroll in far enough, then you can see the moons, and then you can really get in quite deep with this program. And also on here's one. Here's a galaxy, this NGC 7309. So anytime you see this little red circle, those are galaxies. Okay, what else can I show you with this program? Oh, I'm going to scroll outwards a little bit. Go down here to this last line. It has constellation lines, so it points to constellations out to you. And if you actually press the thing next to it, it gives you the names of the constellations. So this should help you out immensely, because a lot of things are labeled by constellations, where they're at. And if you're trying to look for an object, you're on, geez, I don't know what these are, and I don't even know what constellations are. Well, this gives you an idea of where the constellations are during that night and what they would look like. So that is Stellarium. I'm actually going to come back to Stellarium because I'm going to show you some more stuff with it later in this video. Oh, here's the Andromeda Galaxy. That's a really nice galaxy to look at. This one will actually have what it looks like if we scroll in, and you can see how big it is. So this is the Andromeda Galaxy, which is M31, and it gives you some other information down here. I forgot to mention, so not only does it tell you the name and the other names, but it actually tells you the RA and declination on here. The RA and declination are important. Those are the locations of these objects. Now, if you're using a dwarf, the dwarf has its selections of what you can look at, but sometimes you might want to image and do an object that's not in their database, so you'd have to get the coordinates, and these are the coordinates where you can get this is the place you can get those coordinates. Now they give you two sets. They give you a J2000 for RA and DEC, and they also give you the one that says on date. You want to use the one that's on date. That's the latest coordinates. Okay, well, that's the Stellarium. As I said, very powerful program. This is only the Reader's Digest version that I gave you, and we're going to come back and use it later. Okay, folks, one more thing, and that is the moon. So you might say, what's wrong with the moon? The moon's a great object if you want to image it. However, when you're doing deep sky astrophotography, you really don't want to image anywhere near the moon. And the more full it is, the worse it is. Right now I click on it, it says it's illuminated 51%. That means it's first quarter. If it's actually a crescent moon, you probably don't need to worry about it too much. That's if it's below first quarter. But if it's actually above first quarter, it turns into what's called the gibbous moon, and then it's going to turn into the full moon, and then it's going to turn into the waning gibbous. Right now, it's going to turn into a waxing gibbous after tonight. Then it's going to turn into a full moon, and then it's in about a week, 2 weeks later, it's going to be the waning gibbous, and then it'll go to third quarter. So if it's first or third quarter or smaller, it's not too much of a problem. But when it's in the gibbous or full moon, it could be a problem. You really want to be on the opposite side, especially if you're imaging nebula. Globular clusters, they don't suffer as much from that masking, from that moonshine. But the reflection nebula and emission nebula, they're really susceptible to it. You'll get all sorts of gradients in it. Watch what happens when I go to look at the Milky Way here, and watch what happens when I click on another day. So here is the next day, and look at the brightness of the Milky Way, and we're going to go to the 27th, 28th, and 29th when it's, look how dim the Milky Way is right now. And that's what really happens when the moon is out. It never really gets completely dark because the moonshine just masks everything else out. Now it's near full moon, and you can't even see the Milky Way at all. Even though the moon is low, it's still enough to cause a havoc. So if you were going to image something, I'd recommend imaging a globular cluster way over on the other side of where the moon is supposed to be. Okay, so that's the moon. Okay, just to let you know, most astrophotographers eventually end up doing a lot of their imaging from their own backyard or front yard, somewhere at their own house. But, if you are going off-site, it's a good idea to check the skies and check the area prior to your imaging. Okay, let's go to the next step. Okay, folks, for this next part, I want to show you how the objects and stars and constellations and whatnot move in the night sky. So for this demonstration, I'm using Stellarium, and I just have a generic landscape showing. Now right now it's showing July 24th at 8 o'clock at night, just around dusk, and I have the constellations highlighted and I have their names also highlighted. All right, now let's watch what happens as I speed things up, and you'll notice what's happening. They seem to be getting higher in the east, and they keep moving in a counterclockwise direction. They're heading west, and they all seem to be pivoting around this little point right here. That point is Polaris, which is the North Star. Okay, I'm going to stop this, and let's see what happens if we face south. And we'll speed things up just like I did before. And they seem to be going in the opposite direction, but really they're not. They're actually still going from east to west. It's just we're looking south now rather than north. Okay, and this is exactly what the sun does it follows the path of the sun. The sun also rises in the east and sets in the west. Let me speed it up so we get a better idea of that. There we go. And here's the next day, and we can see the sun rising in the east. And when it gets to the west, it sets. When it crossed the meridian here, which is the 180 or 0 degree line, that's when it reached its highest point. Really, it's not the stars and constellations and whatnot that are actually moving. This is being caused by the Earth's rotation. Remember, the Earth rotates 24 hours, it makes one full rotation, and that's what makes it appear that the stars are actually moving. Not to be so northern hemisphere centric, I've decided to show you what it would look like in the southern hemisphere. So I'm at the negative 28 degrees 14, and I'm 125 degrees east. Actually, it's at the Byron Bay Observatory's coordinates, which is Dylan O'Donnell's home place. Anyways, let's see what happens. I'm at the same day, and I'm going to speed things up a little bit. We're looking north in this case, and it looks like it's moving the opposite direction as it did in the northern hemisphere when we're looking south. But it's really not. it's rising in the east because east is over on this side and west is over here. So things are moving east to west, even in the southern hemisphere as well. It just looks opposite because they're on the southern hemisphere. And indeed, the sun, even in the southern hemisphere, also rises in the east and sets in the west. And it reaches its maximum height when it hits the meridian, as you'll see in a second. Okay, now let's reorient towards the south. We're still in the southern hemisphere at the Byron Bay Observatory location. And let's see how the stars and the constellations move around down here. And again, it's sort of moving in the opposite rotation. When we're in the northern hemisphere, when we were actually moving in a counterclockwise direction, here we're moving in a clockwise direction. But again, it's going east to west. And you'll notice what it's pivoting around. Or I should more or less say, you notice what it's not pivoting around. There's no southern pole star. In the northern hemisphere, we have Polaris. In the southern hemisphere, why, there's really nothing to pivot around. So doing stuff in the southern hemisphere might be a little bit tougher at times. Okay, I just wanted to show you a couple other things here. If you're ever looking for the North Star Polaris and you're in the northern hemisphere, why, by golly, you look at the coordinates here. Polaris is about 41 degrees in altitude in the northern hemisphere at my location. Now, my location in Monroe, Connecticut happens to be 41 degrees north latitude and 73 degrees west longitude. So it turns out that Polaris, to find it, all you need to do is find your latitude. So if you were in Phoenix, Arizona, the latitude there is 33 degrees north latitude. So you would just look up in the northern direction at 33 degrees, and sure enough, you'll find Polaris, the really bright star, which is a North Star. Okay, now what do I want to show you right now? I've got it in the Alt-Az coordinate system, that is this. And let's take a look at which way, let's look at the constellations, how they move with regard to the coordinate system. So right now, the constellations and the stars and everything are moving, but the coordinate system is staying put. So the coordinate system, Alt-Az, is relative to us, and 10 degrees altitude is always 10 degrees altitude, 20 degrees is still always 20, 30 is still 30. And I'm now going to switch it to the, and turn the Alt-Az coordinate system off. I'm going to turn the right ascension coordinate system on. Okay, so in the equatorial coordinate system, watch what happens when I move the objects ahead. You'll notice that the stars, constellations, and whatnot, they move with the coordinate system, and it's not relative to us. So that's the big difference. This will be more important when I talk about the next item, which is Alt-Az mounts versus equatorial mounts. So let's go to that. All right, folks. In this next part, I want to show you, or go into a little bit about equatorial tracking and alt-azimuth tracking. Now, alt-azimuth tracking is what this thing does. It's the simplest type of tracking. Basically, for altitude, that's alt, it's your up and down measurement. And for east-west, that's your azimuth. You just move it like that. Most bird watching, regular photography mounts do alt-azimuth tracking. Now they have their advantages and they have their disadvantages, which I'll show you shortly. Now let me show you what equatorial tracking, what that looks like, or an equatorial mount looks like. Alright folks, well this is an equatorial mount, and you'll notice it doesn't look at anything at all like an alt-az mount, and in fact it's all like tilted, if you will. Basically what it is the mount is actually already oriented towards Polaris. So this axis is pointing towards Polaris. And the way it moves is, if you turn this, it has this type of movement. And it also has this type of movement. So you can sort of see what you're going like this. It has that type of odd movement. Now, this also has some definite advantages when you're doing astrophotography, long exposure astrophotography. Now, fortunately, the Dwarf can actually do both. If you orient the Dwarf II Polaris, you can actually do equatorial tracking. Now, let me show you what the advantages are on Stellarium so you'll know what I'm talking about. Alright, so I'm going to use Stellarium to demonstrate the differences between an equatorial versus an alt-az mount are. Now, both mounts track. Indeed, they track pretty well. But watch what happens. So I'm going to focus you to Cepheus here, and watch what happens when I turn it on. So notice how Cepheus is starting to go up, but notice the orientation of Cepheus is actually moving. That is known as field rotation. Although it's tracking it, the mount would be tracking it right now, it's still going to rotate, okay? Because earlier, so if we go backwards, I mean, here it was oriented up and down, and when we started, it was more or less horizontal. So your alt-az tracking will work for about 10 or 15 minutes because the field rotation will not be that bad, that amount. But if you were doing an hour or so, that field rotation would actually be a problem. So if you have it set in equatorial mode, all right, if you've got your mount that is equatorial mode, it's actually set towards Polaris, and watch what happens with the constellation relative to the equatorial grid, which I have selected right now. It remains with the grid, and that's how your mount would be oriented too. Your mount would take care of that field rotation, so it wouldn't matter. You can image for hours and hours if you needed to, using with an equatorial mounting system. So that's the benefit. The Dwarf II can do alt-az tracking, but it can do equatorial tracking if you have it set towards Polaris. Hi everybody, for this next installment I just want to bring to your attention some additional weather apps and some astronomy apps that you might want to get for your cell phone. Okay, a couple of additional weather apps that you might want to download in addition to your normal Weather Channel app. The first one I want to show you is this one called Clear Outside, and it's a free download, and you can actually get this one for the computer too, and it's really helpful. It pops up with United Kingdom, but you want to put your just current location, and it prints out and it gives you Monroe, Connecticut. That's where I am. It tells you your coordinates. It also tells you up at the top your Bordeaux class, and it gives a great indication of what the upcoming weather is, and it tells you all this other stuff like whether the moon's out, high clouds, low clouds, and that's what's most important. And you can actually move it, and you can see tonight is not going to be a good night to do any type of imaging. It's going to be cloudy. Where it's red at the top where it says time, that's not good. You really want it to be green. It's not looking good for the next couple nights. Oh, wait a minute. Here we go. Looks like Saturday might be a good night. Friday or Saturday. I'm not sure what day that is. All right. Another one that's really handy is this one called Atmospheric. And this one, it actually is really good. I love it because it actually shows you up at the top. It has a map, and you can actually scroll ahead to see what the weather is going to be. And it looks like it's going to be clearer according to this weather app. But more importantly, down below, it also gives you cloud cover, and it's actually clear right now outside at 10 in the morning. But it also has two other things here. Down below the cloud cover, it says transparent, it has seeing. Transparency is an indication of how clear it is in the atmosphere, meaning it might be clear outside, but for deep sky astrophotography, it may not be good. There's little water vapor and particulates in the atmosphere that might interfere with deep sky astrophotography, so that one's important for that. The other term, seeing, Now, seeing is not for deep sky astrophotography. That's if you're doing planetary, solar, or lunar work. Seeing is more important, and seeing doesn't have to do with water vapor in the air. Seeing has more to do with little atmospheric disturbances, like if the air is turbulent, if the jet stream's going overhead. So seeing is mainly for planetary work, and transparency is mainly for deep sky astrophotography. All right, they also have these astronomy apps, and a few of them you might want to check out, or a couple of them that you might want to check out. One of them is called Sky Tonight, and basically if you hold them up, they're actually a live view. They tell you what stars and what the constellations, where they are. Now it's in the daytime right now, that's why it's blue. At nighttime it would be dark, but if you just hold it up in the direction of the object or the area of the sky, it'll tell you what you're seeing live view. So that's kind of handy, especially if you're just getting started. Right now I'm facing downward, so it's seeing through the earth. This is what would be available if you were in the southern hemisphere at night. So that's kind of neat. And another one is that Stellarium. Stellarium has a app that does the same thing that this can do. Although the Stellarium app for the cell phone, that costs money. So this Sky Tonight is free, and Stellarium costs money. Okay, just thought I'd point some of those things out to you. Okay, folks, just a few final thoughts here. If you're going out in the field, don't forget to bring some bug spray. Very important. It gets kind of buggy out there in the middle of the night. And if you're going out in the wintertime or in early spring or late autumn, it gets really cold at night, so don't forget to dress warmly. And also you might want to bring some little battery packs for your iPhone or your tablet device or something like this, because in case you run out of juice. With the Dwarf, all you really have is just the little internal battery here and a cell phone and a tablet, so this is very, very portable. Unlike this thing, if you're using the big mount here, you better have a big battery supply for that. So the Dwarf makes it a lot easier in that case. Oh, so the other thing you're probably going to want to have is a flashlight. But you want to make sure your flashlight has a red light on it. You don't want to have a white light, because white light is going to make your eyes very uncomfortable because they're already accustomed to darkness. And if you were at a star party or if you were out there with other people and you flashed your normal white light flashlight, you are not going to be a popular person. Okay, I've already had some time to use this already. We had a couple clear nights, and boy, this thing was fabulous. It was super quick and super easy to use, and I can't wait to get out there and use it again. So I am going to do another video. It's going to be a short tutorial on how to collect data using the Dwarf, and I'm going to take that data and I'm going to process it to produce an image. Well, I'd like to thank Dwarf Labs for letting me review this, and I'd like to thank you for watching this video, and we'll see you next time.